Hi guys, so today I'm here to show my new robot here. So this was inspired by the 2026 FRC competition called Rebuild. The entire part of the FRC competition called Rebuild for this year is to shoot as many balls into an elevated place called the hub, which is an hexagonal place with a hole. Our goal is to shoot foam balls into that hub. So now you know what the FRC game for this year was, then let me explain what my entire design process was. Due to the fact that this is in fact my second time making a shooter bot, this was kind of a contemplation for me because this was my first time making not only one, two, but a whole lot of multi-balls being into a hopper and shoot, not one at a time, but two at a time. So this was kind of a very different situation compared to my earlier robot, which had the limit of the balls you can carry, but for Rebuild, there wasn't. So instead of using ginormous dense balls made out of foam, I decided to use these 24mm diameter Vex plastic balls. These came in some of my Hexbug Vex kits, and I decided to kind of use a pile of them, cause I, well, have an entire cup of them, and this is not the only cup I have. For my robot, for the shooting mechanism, I know that I need a lot of RPM, but enough torque to shoot these balls. However, speed and torque cancel each other out, so I need to find the exact gear ratio. Starting with the basics, I decided to make the drivetrain. This was very common drivetrain that I used, and it's just two motors. Sometimes I did kind of decide to kind of gear it down, but this time I didn't gear down. And yep, it's a direct transmission on both wheels, and I tried to get some Omni wheels for Lego Technic, but they didn't have. So this time I decided to use these genuinely, what do you call these, plastic wheels? Yeah. And the difference from my regular drivetrains and this drivetrain is that usually I use only one wheel here, but this time I used two wheels stacked together. And instead I didn't put any shaft covers here, hoping that the friction itself is enough to kind of hold it. And this turned out to be better with the traction problem that I had with the ground. Each LEGO medium angular motor generated by LEGO Spike motors are around 120 give or take 5 RPM. Using this idea, I decided to, instead of doing one motor for the shooter, I decided to do two motors, stacked and connected, with the same gear ratio on each side. As many engineer knows, symmetry is our best friend here. If I give a very quick demonstration here, let me load up some balls in my chamber, kind of get it on double lane format, because that's easier for me. And if we press this, oh, I forgot my guards were down. We don't need that right now, don't we? So as we can see, let me just turn on my shooter only. The shooters are extremely fast, so if I put one here. Now, capping the entire turret here was very big deal that I had. So the white part here, as you can see, is kind of messy. And this was 3D printed with basic PLA. So there is, I believe, a 1mm compression with this, so it's pretty snug when it goes in. And this white part took a lot of iterations when we see. And I have an entire whole pile behind me, but I also got other piles, so I can't show you that. However, I came through a lot of problems, starting with how to kind of guide the ball instead of like going this way, or try to come out the straight way from what I see. So one of my first edits I made was this curvature I had. A lot of teams do that if they have a single shooter, but because I have a double shooter, it sounds kind of erotic. However, if we kind of look at all the advantages, sorry, I got a ball stuck here, got it. As we can see, when the ball comes out, it's all centered, and it doesn't like travel all the way from here to here, and it always has a maintained compression with the wheels, so that kind of helps when you're shooting at high rates. Another reason that I had is the distance. So I did know the measurements of the diameters of the balls, which was 24 millimeters. However, trying to see how each kind of worked was kind of hard because sometimes I'll kind of miss some of the calculations on my CAD, and the space would be just small, so even the ball wouldn't fit through, even the tires wouldn't fit through, and as you can see, the ball is a little shorter than the tires. It's kind of hard to see. But anyhow, after around 26 attempts from my CAD and simulations and unfortunately 3D printing, I finally got the sweet spots with some pocketing I have here. You might be wondering what these two edge wheels are. Usually I had bigger wheels, but because of my other project, I kind of took them away, so I was kind of forced to use these. And this kind of is like an inertial wheel, so it kind of gains weight. Usually you have a metal wheel that is attached like directly on the shooters. So if you have enough power on your motors, then it really helps with consistent power. However, well, I don't have a metal 3D printer, so it's kind of out of my hands. So instead, I use these tires to try to get us maximum weight. And this kind of helps with a little more torque. So usually I'm allowed to shoot around 4 to 5 balls at a time if possible, and they all go into the bin that I've assured. After getting the shooter done, one of my biggest questions was the intake and the hopper. Starting with the hopper, I wanted to have a belted system. However, I learned that because of my low torque on this and my current problem with the friction here, I kind of had some problems with my designing my hopper and having a belt system. So instead of belt system, I decided to kind of create my own jostler. Now, a video that I saw from Fun Robotics Network was that Team 973, the Greybots, they made in a way a jostler using their intake, and that was kind of cool to me because when the balls get jammed, they just keep pushing, and that kind of like unjams all the balls, and I thought that that was kind of very smart. So I kind of made my own, and this one is kind of like, oh, it's like this. So it's a little tilting mechanism as we see. It's a 1-to-1 gear ratio, and I got a ball stuck here, and I can't get it out. Yeah. You will stay in there until the rest of the video. Oh, I got it out. Yay. So what we see here is that there's a little bit of hot glue that I put on the edge, so that kind of helps with the traction when it's going into the balls. And this took a lot of iterations, such as these rubber bands, which were used on my original intake. If you're curious on what happened to my intake and some prototypes that I did, you can see all my shorts in my channel, the Robo-Nerd. However, because of my motor shortage and the fact that these balls are too small for all my tire types, I just needed smaller wheels, and making smaller wheels was not that easy for the resources that I had. So in a way, I didn't give up on the intake, but in this video, yeah, I took it off. So usually I had a ramp with wheels, and that just kind of helped go up. And these rubber traction wheel would just have it tossed into the hopper, and from there I will just and as you can see, I did slow mode, and these kind of helped on trying to get all of the balls out. As you can see, I wonder what happened to another ball. And just more on my hopper. Let me just take that out and kind of latch them on the side quick. So when we take out everything, I'm gonna just, because I have this all gone, it just flips up. And this is kind of fragile because I have a one belt system here. And I feel like I just broke it again, but it's fine. Good. So as we can see, let me and this kind of allowed me to kind of in a way have all the control with the... Okay, well, that thing did not cooperate with me, so here it is. So this is one of my main coupling parts here. And as you can see, it just slides straight in here, like this. And using this pin here, I was connected to this wire here. And more on my jostler, it is interestingly reinforced with tires in the back. So it's kind of like a carrier. And the balls just sit quite nicely in there. Then when they go out, I have kind of this white funnel piece, and it just shoots out into the shooters. And from here, if I just put this, whoops. And on the robots, these two H pieces kind of help with just limiting how much the ball can roll. And this has a very good incline, as you can see. Please don't go away. And onto my controls now. Let me just put this back in. Good. So what I used is I used the Mindstorm mouse and connected my Xbox controller that I had lying around. And this is the only controller that I have that is actually functional. And I don't play games myself, so this is the only reason that I use it for. So this is a tank drive, as you can see from the above screen, and I can just turn. This is not a smooth surface, as you can see, so my studio is kind of bad in English. And how everything just works is that I have A and B here, and as you can see, B raises it, A lowers it, B raises it, A lowers it. Simple. Now onto the shooters. I have manual controls here, so I can either press LT for forward. And as you can see, I do have code for instant stopping, and if I press LT, interestingly, the inertial wheels have a better effect on here. As you can see, even if I let go, it still spins because of the inertial wheels. And I have the automatic shooters, so if I press RT, it's forward. It's just going forward infinitely. And from here, I have X, which is my auto, which is to shoot, come back to the human player station, load up the balls, go forward, and then shoot again. So this is my right trench slash right bump auto. And yes, because my intake's gone, I have the auto. And Y is just automatic shooting. Let me show you an example. Let me just two balls here, and if I press Y, and it just shoots, and it just stops. And it's back to manual control, so it's a lot more easier for me. This robot took so many iterations and time. This project expected to be taken around less than a month, and because of my current schedule and my entirety of Vex related stuff, this was not the only thing that I've been making, so as you can see, it's kind of in a battered state. One thing I also mentioned, talking about iteration, is that relating to one of my designs, I actually wanted to have an overhead shooter mechanism. So instead, the balls, for my design currently, it's into the hopper, into the wheels, and shoots this way. But instead, what I wanted to do is hopper, wheel, it'll spin, and go this way instead. But that just took so many torque away from my robot. So as you can see, I used the soldering iron, and I just cut through, tried to leave around 30 degrees depression for my new turret. Now to sum my entire project up, this thing took a lot of time, but I'll say it's worth it. Cause not only was this one of my biggest dreams of creating a shooter bot that can shoot multiple balls at a time, it was one of the most complex robots, especially the fact that this is my first ever robot that has a 3D printed piece attached to it. Now I would say this project will now come to an end. Thanks, bud. You may go. And now this is not my only project working, so now wait and I'll feed you more content. I guess after a few months of grueling time and experience, this robot is now officially retiring. From all the fun stuff, from all the failures, from missing the bin entirely, from shooting my own belly so many times, this was now a successful project. This was my explanation for my Mini-FRC rebuilt robot.